The first example of why we scan across all wavelengths is because we need to set our spectrometer to measure something that other than a red wavelength so that we can find the lambda max. And the second is because we have to run an absorbance scan across all wavelengths to select the one that absorbs the best. Scanning across all wavelengths relates to finding the lambda max because this is necessary to ensure high sensitivity and minimize any form of deviation from Beer's law. The lambda max is the wavelength at which the maximum absorption occurs. There are four variables in the Beer-Lambert law, which is an equation that relates the attenuation of light to properties of a material. As demonstrated in our lab practical, this relation can be exercised to determine the concentration of a chemical in solution from using the spectrophotometer. First, there is the absorbance, which is represented by A. Then there is the molar absorbability of the particular type of matter in the water sample measured by the Greek letter epsilon. Next, there is the L, which represents the length of solution that light passes through. Lastly, C stands for the concentration of the solution. Now, in order to use this equation, one must understand how the value of each of the variables is determined. The absorbance value is measured by placing the solution in the cuvette into the spectrophotometer and using simple reads. The molar absorbability is usually given to you. However, if it isn't, you can manipulate the equation to solve for the molar absorbability instead of the concentration. Since L is the path length of the sample, it is the width of the cuvette, which is 1 centimeter. Lastly, the concentration sample will be the X value, so we will have to find the absorbance, and once we do that, we will be able to manipulate the equation to A divided by E times L equals C. The relationship between absorbance and concentration is directly proportional. The absorbance of the light absorbing matter in water is directly proportional to its concentration. You must be careful to remember to zero the machine with a blank before scanning for the absorbance value because it negates the effect of the water molecules and solely takes the absorbance of the solution's concentration into consideration.